In this video, we learn about cumulant generating function and probability generating function of binomial distribution, CGF and PGF of binomial distribution. Let us see. The cumulant generating function of a binomial distribution is given by kx of t is equals to log of mx of t. Remember that. This is the definition of kx of t, means cumulant generating function. The cumulant generating function is nothing but the logarithm of moment generating function. I repeat. Cumulant generating function is nothing but the logarithm of moment generating function. So kx of t is equals to log of mx of t. Kx of t is equals to log of mx of t. Log of what is mx of t? Mx of t is given by q plus p e power t whole power n. P e power t whole power n. So log of q plus p e power t whole power n. This is nothing but n into log of q plus p e power t. So kx of t is equals to n into log of q plus p e power t. Let us expand. Let us simplify this one. So log of q plus p e power t. We know that the expansion of e power t. We know that the exponential function expansion. So that is here. 1 plus t square by 2 factorial plus t cube by 3 factorial and so on. That is nothing but the expansion of e power t. Expansion of e power t. So now simplify. Multiply with p into 1, p, and the remaining terms as it is. P into t plus t square by 2 factorial plus 2t cube by 3 factorial plus and so on. Now we know that but from the binomial distribution, the value of p plus q is equals to 1. From the binomial distribution, the value of p plus q is equals to 1. So by using that fact, this can be written as 1. So n into log of 1 plus p into t plus t square by 2 factorial plus t cube by 3 factorial plus and so on. Now you observe that this is nothing but log of 1 plus x formula. This is nothing but log of 1 plus x formula. Log of 1 plus x is equals to x minus x square by 2 factorial. I think there is no factorial. I'm sorry. X square by 2 plus x cube by 3 and so on. There is no factorial. Observe that. Log of 1 plus x formula. This whole term treated as x. It means you get log of 1 plus x. By applying log of 1 plus x minus x square by 2 plus x cube by 3 and so on. So this is the kx of t. From this kx of t, we can write mean and variance. Mean k1 is equals to coefficient of t in kx of t, that is np. And variance k2 is equals to coefficient of t square by 2 in kx of t, which is nothing but np. So from this expansion, you can write the mean and variance also. The mean k1 is given by coefficient of t in kx of t, which is nothing but np. The variance k2, this is nothing but coefficient of t square by 2 p square by 2 and kx of t, which is equals to np. Now let us see the probability generating function of binomial distribution, which is also simply denoted by PGF. PGF, probability generating function of binomial distribution. First, we write the definition of binomial distribution. Let capital X be the random variable following the binomial distribution with parameters n, p. Capital X is a random variable following the binomial distribution with parameters n, p. Then probability of x is equals to x is equals to p of x is equals to ncx p power x q power n minus x. Now the PGF of a random variable is given by px of t is equals to expectation of e power tx. Px of t is equals to expectation of e power tx. The expectation of e power tx is nothing but summation x is equals to 0 to n t power x into p of x. T power x into p of x. What is p of x? Probability mass function of binomial distribution. What is P of X? Probability mass function of binomial distribution. Now simplify summation x is equals to 0 to n t power x ncx p power x q power n minus x. Again these two terms t power x and p power x. T power x and p power x. They can be together written as tp power x. Observe that t power x and p power x can be written as tp whole power x. So now expand, remove the summation, put x is equals to 0, 1, 2, 3 and so on small n. So if you put x is equals to 0, you get this nc0 tp power 0 q power n minus 0 and then plus nc1 tp power n 1 q power n minus 1. Here it is x is equals to 0, here it is x is equals to 1 and here it is x is equals to 2. X is equals to 2. nc2 tp power 2 q power n minus 2. If x is equals to r, we get ncr tp power r q power n minus r. Again this is nothing but the last term is ncn tp power n q power 0. So this is nothing but the whole expansion is nothing but binomial expansion x plus y whole power n. Binomial expansion x plus y whole power n. Instead of x we have tp, instead of x we have tp, instead of y we have q. That's it. tp plus q whole power n. Therefore px of t is equals to q plus pt whole power n. So these two are also important for 5 mark section. Derive PGF and CGF, cumulative generating function and probability generating function of binomial distribution. Sometimes they may ask that derive the mean and variance. Derive the mean and variance of binomial distribution by using cumulating generating function. Function may be like this. Derive the mean and variance. Derive the mean and variance of the binomial distribution by using CGF or cumulative generating function. Cumulative generating function. So learn these two. Keep learning. Wish you all the best.